Hi students, this is Sivakumar, 11th standard mathematics, chapter number 1, example 1.3. To prove that A union B dash union C dash intersection A intersection B dash intersection C dash union of A union B union C dash intersection B dash intersection C dash, that is equal to B dash intersection C dash. Okay. For proving this result, I take an example. If we understand that example, the proof will be very easy. For example, let I consider set A that is equal to 1, 2, B that is equal to 2, 3. What about that A intersection B that is equal to 2 only, correct? Common. Intersection means you have to write the common elements. So which one is common? 2 alone. And A union B that is equal to, we have to write all the elements of A and B without repetition. So what are they? 1, even though double 2 have to write only 1, 2 and 3. 1, 2, 3. Okay. Now, therefore, look at that set A is subset of A union B. Is it correct? Set A that is equal to 1, 2 and A union B that is equal to 1, 2, 3. So all the elements of A in the set A union B. Therefore, definitely A will be the subset of A union B. Now, A intersection B, that is the subset of A, correct? A intersection B that is equal to 2 only. That 2 is in A. Therefore, A intersection B is a subset of A. So, A intersection B is a subset of A as well as A intersection B is a subset of A union B. Obviously, correct. A intersection B here it is, A union B here it is, the 2 element 2 here also. Therefore, A intersection B is a subset of A union B. Let it be 1. Suppose, let A that is equal to 1, 2, even B 1, 2. Now we can find A intersection B. What are all the common elements? Both 1 and 2. And A union B, write all the elements of A and B. Once again 1 and 2. Even though double 1, double 2 have to write only 1 and only 1, 2. So A union B over. In that case, A intersection B is equal to A that is equal to A union B, correct? A intersection B that is equal to 1, 2, A is equal to 1, 2, A union B also 1, 2. Even B, but I didn't take that one. I have taken only A intersection B, A union B. Now, comparing these two, equation 1 and 2, from 1 and 2, what is the conclusion? A intersection B, here also A intersection B, right? A intersection B. Here subset, here equal. So together subset or equal. Here A, right A. Okay. Again I tell you, A intersection B here. Here also A intersection B, write A intersection B. Then here subset, here equal, together subset or equal. A, here also A. Here subset, here equal, together subset or equal. A union B, write A union B. This is the final result. Always intersection is the smallest set. Smallest. Union is the biggest set. Always. So it has small number of elements. This one is more number of elements. It's the biggest set. This is a superset. We can say what it is called, superset. Right? This example only for your reference. You no need to write this example in your examination. This is only for your reference. Okay. Now we get into that a problem. Example 1.3. Okay, note down this example. Here write A intersection B inside the brackets, even A union B inside the brackets. Out of these three, which one is common actually? Here A, here also A. Note down that. That will be useful while working out the problem. A. Then I had to explain one more example for making you to understand this problem very well. And listen, let A that is equal to 1 comma 2. I take 1 comma 2. And B that is equal to 1 comma 2 comma 3. Find A intersection B. A intersection B that is equal to common elements 1 and 2 only. Correct? And A union B that is equal to, write all the elements of A and B without repetition. Double 1 have to write only 1 1, double 2 have to write only 1 2, and single 3. So I have taken this example now. A intersection B, whenever intersection comes, when comparing the two sets, which set has less number of elements? That will be the result whenever intersection comes. Out of these two sets, which set has less number of elements? 2 elements, here 3 elements. So that A. Condition, the elements of A must be in set B. Elements of A, elements of one set must be in the other set. Here 1 2, here also 1 2, the one extra element also there, 3. Now look at that A union B. Whenever union comes, we have tried that the set which has more number of elements. Out of these two sets, which set has more number of elements? B set only. So that is equal to A, that is equal to B. Condition, one set, all the elements of one set must be in the other set. One set has more number of elements. Here 1 2, here also 1 2, here one extra element. Now we can get into that problem. Proof for example 1.3. Listen carefully. Here, particularly this portion, which one is common between these two? Here A, here also A. In question I have written C dash, that is not C dash, C only. Change it. Here B dash, this is B dash. Okay, now can get into the proof. we know that A is a subset or equal to A union B dash union C, the right hand side. The left hand side you have to write A intersection B dash intersection C dash, subset or equal to, according to this note. This one. What is in the left hand side? We have intersection. Right hand side we have union. Look at that. Full of intersection. Here full of union. Have taken these two from here only. This is full of intersection. Here full of union. Have taken the common one, A at the middle. Okay. Therefore, A union B dash union C intersection A intersection B dash intersection C dash equals. When comparing these two, if intersection comes now, we have tried that least one. Between these two, which one is the least? Always the intersection is least. Again I tell you, if union comes, you have tried the set which has more number of elements. Whenever intersection comes, you have tried that set which has less number of elements. Out of these two, less number of elements, obviously intersection set only less number of elements, because these two are union. So I have tried this result, A intersection B dash intersection C dash. Okay, let it be number 1. And now I take C dash is a subset or equal to A union B union C dash. The left hand side B dash intersection C dash. This one here we have here C dash, there also C dash, have taken C dash over here at the center. Out of these two, which one is the least? Definitely intersection is the least set. So that have taken B dash intersection C dash to start with. This is the least number of elements, a set with the least number of elements. Since we have union, this is the set with more number of elements. This is a superset. So A union B union C dash over here. Therefore, A union B union C dash intersection B dash intersection C dash equals. Once again, between these two, what symbol? Intersection. Whenever intersection comes, you have to write the set which has less number of elements. This is full of union, this is intersection. Definitely this set only has less number of elements. So that the result is B dash intersection C dash. That is number 2. Therefore, we have tried the question now. Question is A union B dash union C intersection A intersection B dash intersection C dash union A union B union C dash intersection B dash intersection C dash, that is equal to this result. Here it is. What is the result? A intersection B dash intersection C dash. A intersection B dash intersection C dash union. This one here it is. What is the answer? B dash intersection C dash. B dash intersection C dash. That is equal to. In between these two, we have union. Whenever union comes, you have to write the set which has more number of elements. Out of these two, which set has more number of elements? Definitely this one has more number of elements, because here B dash intersection C dash, here also B dash intersection C dash. Apart from that, we have one more intersection. Since we have one more intersection, this set has less number of elements when comparing B dash intersection C dash. Therefore, the result is B dash intersection C dash. So this set only has more number of elements than this set, because for union you have tried the set which has more number of elements. So B dash intersection C dash is the answer. Look at the result. We have proved B dash intersection C dash. So I have taken LHS here. I have proved that RHS here. So example 1.3 is completed. Before proving this problem, please refer this example and this example also. Then only can understand this proof. So example 1.3 is over.